Here's our introductory lecture to pointers, and we're going to talk about declaration and assignment. So first of all, remember that objects have 5 properties. So first of all, they have a type, they have a cool name or an identifier, they have a value, they have an address, and they have scope. Well, a pointer is an object that has as its value an address. So pointers have addresses as values. So remember to declare just an integer. We can say something like int x is equal to 5. Now out in memory, there's a memory location, and in that memory location there is the value 5, and we can refer to it in our program symbolically using its identifier x. Pointers must point to specific types. So for example, if I want to make a pointer to an integer, then I write the type and then I append the asterisk at the end of that type, and this lets me declare a pointer to an integer. Now I give my pointer an identifier, and in this case I am going to assign it to point to null. So here I'm using the constant 0 as null. So what this does is this makes x pointer point to null. And this is analogous to assigning 0 to an integer or 0.0 to a double. Now in memory, this object has a memory location, and in that object and in that location we're going to store an address. And the way we draw this is just using an arrow. Say it points to null, and in our program we can refer to this memory location using the identifier x pointer. So how do I assign x pointer an address? There are various ways to do that, and we'll learn about those going forward, but in this simple program or this simple code fragment, here's what we're going to do. There is an address operator, the ampersand, and it returns the address of some object. So in this case, this expression will evaluate to the address of x. And if this evaluates to an address, then we can use assignment to store that address in x pointer. After we execute this statement, we say that x pointer points to x. So x pointer no longer points to null because it no longer has the null pointer as its value, but it points to x. Now if we wanted to print the value of x, then we can simply write cout x and then give a little end line there. And our output, this program or code fragment will write 5 to the console. Now as this picture implies, we certainly can access 5 and print 5 using x, but this diagram suggests that we can also do it through x pointer. We might be tempted to write something like this, and this would not be correct. What we're doing here is we're printing x's value, and this statement also prints x pointer's value, which is an address. It's actually not what it's pointing to. And we'll do this, we'll actually print X pointer's value or something analogous to X pointer in the next video lecture. But we have to differentiate between X pointer's value and then the value of the object that X pointer points to. And to do that, we have to do what's called dereferencing X pointer. So this asterisk is called the dereference operator. And what this does is this evaluates to or returns the value of the object that X pointer points to. So now we're going to print 5. And just to recap, this is the address operator. Okay, and it just returns